Now let's move forward. Now next concept is time period, TP, right? Now first of all, what is time period, TP? Okay, time period is denoted by TP. It is nothing but a time taken by the motion to repeat itself, or it is a time required to complete one cycle. Okay, so let us say that this is a spring mass system. Okay, K and M. Okay, now basically, guys, I have explained you the two concepts. One is the spring mass system, and second one is the which concept? Simple pendulum. Okay, in both the cases, there was the oscillation, there was a cycle, but each and every time I will be considering a spring mass system because it is very easy to help you to understand. Okay, so let us say that I am applying a small external excitation, giving a small initial displacement x. This spring mass system started vibrating. Okay, if the spring mass system started vibrating, and let us say that you got a graph. You got a graph of what? You got a graph of T versus A. What is A? A is nothing but the amplitude. What is amplitude? Amplitude is nothing but the maximum displacement. We have already seen in the last lecture. Okay. Now let us say that you have got this graph. Okay. So let us say that this is the point A, this is the point A, and this is a point P. Okay. Small b. Okay. And let us say this is a time. Okay. So this time is nothing but a TP. So what is TP? TP is nothing but a time taken by a motion to repeat itself, or time required to complete a one cycle. Okay, so on the t-axis, basically this graph is called as a time response graph. This graph is called as a time response graph. What is response? Amplitude. Because in vibration, amplitude is your ultimate response, or amplitude means what? X, right? Amplitude is the maximum displacement, na? And let us say x is the displacement, and capital X is equal to A. What is capital X? Maximum displacement means what? Amplitude. So on the y-axis, I have taken the amplitude. Okay, and on the t-axis, you will get a respect to time period. I hope it is clear to you. So what is time period? Okay, so time period. How will you calculate? Time period is always 2 pi upon omega. What is omega? So basically, omega is nothing but the frequency of external excitation. You can write this formula like this: Tp is equal to 2 pi upon omega n. Okay, so from omega n, you can also calculate a time period, and from omega, you can also calculate a time period depending upon which time period you want. Time period for the natural frequency, or a time period for a external excitation frequency. But always remember that omega n is a natural frequency and omega is the external excitation frequency. ह्या दोन गोष्टी कानामध्ये तुम्ही काय म्हणतात, मनामध्ये, कानामध्ये, डोक्यामध्ये फिट करा, ओमेगा आणि ओमेगा एन. सी देयर आर, सी as I proceed, you will get to understand different notations, right? For example, now we have understand what is omega, then you have understand what is omega n, then we have omega p, we have omega d. Okay, so this notations will go on increasing. So now first of all, forget about omega p and forget about omega b. I am not interested currently in that, but now I am interested only in omega and omega n, and I hope you have understood these 2 points. Omega is the frequency of excitation. Until you have understand that omega is equal to omega n, you will get a resonance. What is resonance? Resonance means what? Excessive amplitude. Amplitude means what? Maximum displacement. Resonance means what? Excessive amplitude. System will fail. And as an engineer, you have to avoid a resonance. Your first aim is to avoid a resonance in any system, and that is why omega is in your, not in your hand most of the times. So omega n you have to design accordingly. Okay. Next, frequency. Now what is frequency? F. Now basically you remember that if omega n is a natural frequency in radian per second, and Fn is also natural frequency which is in hertz, right? Have you understand the difference? F omega n is obviously a natural frequency but radian per second, and Fn is nothing but the hertz, right? And this Fn is always equal to 1 upon omega n, right? 1 upon omega n. So that we'll understand later on. Okay. So number of cycles per unit time is known as the frequency. The number of cycles per unit time is known as the frequency, right? And very sorry, actually f is not equal to 1 upon omega. F is equal to 1 upon time period. So this frequency is equal to 1 upon time period, and time period is what? 2 pi upon omega. Okay. So f, what you get? Omega upon 2 pi. So basically your f you will get omega n upon 2 pi, right? So basically f is equal to 1 upon 2 pi multiplied by omega n. म्हणजे जर तुम्हाला ओमेगा एन माहित असेल रेडियन पर सेकंड्स मध्ये, तर तुम्हाला काय करायचंय, f कसा कॅल्क्युलेट करणार? Fn is equal to 1 upon 2 pi multiplied by omega n. हा फरक लक्षात घ्या. Okay, and every time frequency should be always in hertz. What is the frequency of hertz? Unit of hertz? Frequency hertz. So always first we will calculate omega n and then you will calculate fn, that is equal to 1 upon 2 pi into omega n. Is it clear, guys? Please message me yes or no. Okay. And last is amplitude. Maximum displacement of a vibrating body from its mean position. Now, while deriving a fundamental equation, already I have explained you what is amplitude. Okay. So x amplitude is it is you can also call it as a. So if you are getting confusing, see what is x? X is nothing but a distance, initial displacement. X is equal to displacement. Basically, you can call x is equal to displacement. Okay, and you can call x dot is equal to velocity and x double dot is equal to acceleration. And you can call a as the amplitude, or you can call capital X as the amplitude. Is it clear? Now, guys, please message me. Have you understand all these three concepts so I can move forward? Now, spring stiffness. Next, what is spring stiffness? Force required to produce the unit displacement in the direction of the applied force. Spring stiffness is basically F upon deflection. Means what? K is equal to spring stiffness, force required to produce unit displacement. Displacement means what? Del. You can write like this, F upon X. Means what? Let us say that, again I am taking example. This is a spring mass system. Let us say this is an N. Let us say you are giving a small displacement X. Let us say K is the stiffness. So this K is equal to amount of force you have to apply on the mass so that there is a unit displacement X. So this is nothing but a Newton per meter. Is it clear? Have you understand, guys, what is displacement? And so what is spring stiffness? Okay. So now degrees of freedom. Now I was explaining you what is degrees of freedom. So here we will understand in the detail what is degrees of freedom. Just give me a second. Hello, guys. Please, maybe due to some technical problem, you are not audible to me. I am audible to you. So please message me. Have you understand all the concepts? What is spring stiffness? What is time period? What is frequency? And what is the formula to calculate it? Yes or no? So I can move to the degrees of freedom. Yes. Okay. So now this is good. Now what is degrees of freedom? Now basically the number of independent coordinates. What is independent coordinates? First of all, let us say again I will take example. You will say, sir, you are taking again and the same example, but your whole syllabus is based on the spring mass system only. Okay, the elements will go on adding. Spring mass system will be there. Maybe shaft will come. Maybe pulley will come. Maybe some mass will come. So these elements will come. But basic, you understand. MCK, we call normally as MCK. MCK, M is nothing but a mass, C is nothing but a damper, and K is nothing but a spring. MCK are nothing but the three basic parameters of a spring mass system. Even if you can take a car, so if you car घेतलं, you can model the suspension system of a whole car into this MCK. So any system can be mathematically modeled into a vibratory system by considering these three equations, MCK. Okay, so that is why I'm always taking an example of spring mass system. So again, you take an example of a spring mass system and like it M. Let us say this is a K and this is a X. Okay, now tell me what is this X? X is nothing but the independent coordinate. This S is called as the independent coordinate. Means what? The number of independent coordinates required to specify the motion of a system completely at any instant of time is called a degrees of freedom. So if you require x1 and let us say x2, then you have a two independent coordinates. I will show you the example, okay? But just try to understand the definition, okay? Now, here, again take an example, a spring mass system K1 and X1. Now, tell me how many independent coordinates are there in this example, which will specify the motion. Specify the motion means what? If you give a small initial displacement X1 to the mass, this mass will start oscillating. Means what? The spring will get compressed and mass will maybe come here, or maybe the spring will get elongate and mass will come down. So mass is moving up and down. There is up and down movement of the mass, and there is a compression and extension of the spring, right? Means what? The system has become a dynamic system. Energy has entered inside the system, right? As a see, try to understand that the ultimate power is nothing but the energy. You can say you can basically I call God as energy. So ultimate power is nothing but energy, which cannot be destroyed. Which cannot be destroyed. It just can be converted into the one form to another form, or you can use that energy for doing your some work. Okay, energy is a capacity. Okay, so energy and work are related to each other, right? Okay. Now my question is, how many degrees of freedom are there? How many independent coordinates are there? So this is an example of a 1 degree of freedom system. Why? Because there is only one independent coordinate x. Okay, which can define the motion. Okay. Next. Now in this case, how many coordinates are there? How many coordinates are there to require the required to specify the motion of the system? Yes, in this example, how many coordinates are
One.
there? Yes.
One.
Hello. Please message me. One, two, three. Just message me because I am your order. Yeah, two. No, yes, Thakur, not one, two. It's one. Okay, it's a two, right? So two coordinates. So in this, so this is called the 2 degrees of freedom system. Now basically, एक गोष्ट तुम्ही लक्षात द्या, your syllabus is only related to single degree of freedom system. See, why? Because as the number of degrees of freedom goes on increasing, 1, 2, 3, 4. Let us say if the number of degrees of freedoms are 2, then it is called as a multi-degree of freedom system. It is called as a multi-degree of freedom system. Multi. Okay. Now there is a subject called as a mechanical vibration. It is an elective subject in your last year where you have this multi-degree of freedom system in your study. But in dynamics of machinery, we are studying only a single degree of freedom system. Single degree of freedom system. First of all, try to understand why single degree of freedom system, because we will be always designing or doing the analysis of such a system which only has one independent coordinate, or where the only one independent coordinate is required to satisfy the complete motion or to specify the complete motion, right? Next. Now in this case, anybody tell me how many independent coordinates are there to specify the motion? This is a vertical spin mass system. How many independent coordinates are required in this system? So be fast. How many independent coordinates are required in this system? How many independent coordinates are required in this system to define the motion? Yeah, two. So this is what? 2 degrees of freedom system. Okay. So this is nothing but a 2 degrees of freedom system. So basically, guys, whenever you are doing the analysis of a vibration system, the first point you have to understand that you have to always look how many numbers of degrees of freedom are there. Because because as the degrees of freedom changes, the number of masses also changes, and again the method to do the analysis means what? Ultimately you have to find out the natural frequency omega. If I say, if I give the system, आता एक्झाम मध्ये काय होणार बघा, एक्झाम मध्ये तुम्हाला ही सिस्टम दिलेली असणार आहे, and they will say find out, they will just only say find out the natural frequency of the system. So you have to find out the omega n. It will be in terms of k upon n. Maybe it will be 2k upon 3n, or maybe it will be 5k upon 6n. Whatever may be the answer, you have to solve. So first of all, you have to understand how many degrees of freedom are. Okay, so it is a 2 degrees of freedom system. Okay, so now you can apply matrix method. You can apply any Holz's method. There are a lot of methods which we'll study in the next year. Okay, but now in this case we are not interested. We are just interested only in the x and x. If I am saying that this is x and this is x, now tell me how many independent coordinates are there? Now how many independent coordinates are there over here? Only one independent coordinate. Okay. Yeah. So now you can easily apply Newton method. You can apply energy method. Okay. You can apply D'Alembert's principle. Okay. So degrees of freedoms are very, very important. Now here, now you can see, now this is a, you can say this is a spin mass system Km, and you can see at the center of the mass, that is the CG of the mass, this pendulum is attached. Okay, and this pendulum is displaced by, now this is a combination of a spin mass system and pendulum. See, I am moving to the tough level now, from the simplest to the tough level. Similarly, in this module, you will be solving a problem from easy level to the mid level to the tough level. Okay, so how it goes on changing. Now it is a combination of a streamer system and vertically suspended pendulum. Now anybody tell me how many independent coordinates are there which will satisfy the motion of a system completely? Yes. Anybody? How many independent coordinates are there? Four. You're stuck over here. Where you see four coordinates? One. Okay. See, na? How you can say that one? Okay. Now here, one is the called x. X is required. Yes, two. The x is required to satisfy the motion of n. And second called theta. Theta is also the x and theta, not y. X and theta. You can see, na? Theta is also coordinate, na? Theta is also parameter which will satisfy because how is the motion of this pendulum? This motion of the pendulum is oscillatory motion means what? There is an angular displacement of the pendulum theta. So theta can be also called as a coordinate because see whenever see x is nothing but a linear. Basically, guys, you understand that this x is nothing but a linear displacement and theta is nothing but the angular displacement. So what is the difference? This is a linear system and this is a torsional system, or you can call it as a rotational system also, right? We will study all this system, how to derive this, okay? So here we have our two coordinates, one is the theta and one is the x, okay? So again, these are the examples of 2 degrees of freedom system, okay? Now, tell me, in this example, how many coordinates are there? How many coordinates are there which will satisfy the motions of m1, m2 and m3? Yes. How many coordinates are there in this equation? No? 3. So how many degrees of freedom? Yes. So now you have, okay, so it is called the 3 degrees of freedom system. Okay? Yes. So now guys, as I move, see, that is why I said that mechanical vibrations, there is no such fix, there is no such, you have to, there is no such fixed logic. You have to continuously change your logic. You have to think differently, think independently. Okay? Okay, next. Now, in this equation, tell me how many, yeah, how many degrees of freedom system are there in this? Now tell me, anybody? Now again, see, now I have made a system complex. I have made a system now complex. So I have taken a pulley now. Okay, see guys, you have to solve this problem. You have to solve this problem means what? You have to find out omega. 2. Rajendra is saying 2. Anybody? 3. Which 3? Which 3? Yeah, 3 is correct. Which 3? See, pulley. Now tell me, x2, x1 and theta, these are nothing but 3 coordinates. How 3 coordinates? How 3 coordinates? See, if you are giving a, let us say if you are giving a small displacement x2 to the mass m2, okay, let us say that mass m1 will displace by x1. So x1, x2. And now this mass is connected to the pulley at the center and the CG is fixed. Okay, so what will happen? This pulley will rotate. This pulley will rotate in which direction? Clockwise direction. Clockwise, na? No, it is in anti-clockwise direction. This pulley will rotate in an anti-clockwise direction. So there will be the angular displacement of the pulley, and that will be the theta. So this is also called as a 3 degrees of freedom system. So this becomes a complex system. Now, here how many degrees of freedom system are there? Okay. Chalo. Now in this example, how many degrees of freedom systems are there? Now this is called as a, this is nothing but a body in a space. This is nothing but the body in a space. Now if I say that there is a body in a space, how many degrees of freedom system are there for a free body in a space? Let us say if you are in a space. So any body, if you place in a space, how many degrees of freedom system will be there for here? Anybody? 6. Okay. 6. Yes, yes. Datta Bhushan is you are exactly, you are exact, you are accurately correct. So you are right. 6 degrees of freedom system. So you can say which 3 degrees of freedom? Phi, theta, and z. So 3 rotational. Okay. 3 rotational and 3 translational. Translational means what? This body can rotate by theta, rotate by phi, rotate by z, and it will translate along x, translate along y, and translate along z. Okay. It will rotate, na? It will rotate about x-axis. Imagine, na? in gyroscope we have studied a question. If I take a body in a space, if you take any body in a space, it can rotate along the x-axis, along the y-axis, along the z-axis. It can rotate. I have shown you that diagram of a car. So we got the three movements. One is a linear movement, sorry, one is a rolling movement, one is a yawing movement, and one is a if you take an example of a gyroscope, you know na if the disc was spinning about the x, okay, and then this x-axis was precessing about the y, and then the couple was acting about this z. So similarly, in a space, we always have a three axis only, x, y, z, and your body can rotate about any three axis, and they can also translate about any three axis because it's a 3D system, na? I hope it is clear. Okay. Now, if I say that if I fix one, let us say if I fix a translational motion, if I fix a translational motion about x-axis, मी काय केलं? मी x axis च्या translational motion ला fix केलं. Now tell me how many degrees of freedom system are there? I can fix na. If I am fixing a translational motion about the x-axis, now tell me how many degrees of freedom system will be there? Anybody? टोटल किती आहे? या फाय टोटल 6 आहेत ना, त्यातला मी एक फिक्स केला किंवा दोन फिक्स केले तर 4 झाले. ओके, सो आय थिंक in the kinematics of machine you also may have studied this. Okay, next. Now this is an example of a flexible pin and last one is infinite degrees of freedom system. Okay, now infinite degrees of freedom system means what? If you take an example of a flexible pin, let us say this, and this flexible beam is fixed between the two fixed ends. Okay, so it can vibrate between the two fixed points with the infinite degrees of freedom system. A flexible beam fixed between the 2 points or connected or fixed at the two ends, and let us say it is vibrating or it is oscillating, so it can vibrate with the infinite degrees of freedom system. I hope you understand this. Okay, so this is all about the concept of degrees of freedom system. Okay. System having, now note, very very important, system having finite number of degrees of freedom are called as a discrete or lump parameter system, right? असे systems ज्याचे discrete or lump parameter system म्हणतो आपण त्याला, म्हणजे ज्याच्यामध्ये finite degrees of freedom system आहे, means what 1 2 3 4 5 and 6, whatever may be the number of degrees of freedom, if they are finite, then the systems having finite number of degrees of freedom are called as a discrete or lump parameter system. Okay, it's a name just given to them. And the system having infinite number of degrees of freedom system are called as a continuous or distributed system. Have you got the difference? A system having finite number of degrees of freedom are called as a discrete or lump parameter system, and system having infinite number of degrees of freedom are called as continuous or distributed systems. Okay, now next part is types of vibration. Now, basically, types of vibration means what? Types of vibrations are basically, you can say, divided into the different types according to the condition. According to condition means what? Let us say according to the actuating force. Now, according to the actuating force, now see, maybe in the next lecture or in a due course of time, we will understand the different types of vibration. So, according to the actuation force, free vibrations and force vibration. Now this is very very important concept. So in module number 3 and module number 4 is about the free vibration, and module number 5 is about the force vibration. Okay, so now after completing, now initially I am explaining the basic concept of vibration, then I will go for the free vibration. Okay, then we have a undamped vibration and damped vibration. Now your module number 3 is free undamped. What is your module number 3? Free undamped. मी तुम्हाला ते नंतर सांगतो म्हणजे काय. And your module number 4 is free damped, very very important, and module number 5 is force. Okay, and the force is always damped, it will come into the bracket. Okay, force vibration system is never damped. Means what? Undamped and damped means what? You are providing some external resistance. आता तुम्ही गाडीमध्ये shock absorber टाकलं, a resistance is what? A natural resistance, so it comes under the undamped. But if you are providing some artificial damping, then it is called as a damped system. And in forced vibration, there is no such undamped. There is always a damp. So this is your model number 3, 4, and 5. And model number 6 all about the balancing. Okay. So that we'll understand later on. Then we have again, according to the external, according to the motion of a system with respect to axis. Means what? Let us say mass is oscillating up and down about the axis of a spring, about the vertical axis, let us say. Okay, then it is called as a longitudinal vibration. So that we have to understand. So about the axis, longitudinal, transverse, and torsional. Then according to the behavior of the system, linear and non-linear vibrations. Now in your syllabus, we are interested only in the linear vibration. Once you go to the ME MTech level, or maybe the PhD level, or maybe some higher education, you will study a non-linear vibrations also. Okay, and according to the magnitude of actuating force, means what? What is the value? What is the magnitude of external exciting force? Means wind velocity कितनी है, or maybe what is the initial displacement x you are applying. So depending on that, you will get a deterministic or random vibration. For example, if earthquake, if the system or if it is, let us say some machines or some structures are vibrating due to the earthquakes. Okay, then what is the magnitude? Depending upon that, it comes under the deterministic and random vibrations. Okay, so I will just finish one or two points and then we will stop. Okay, okay. Now first of all, free vibration. Now guys, your model number 3 is free undamped vibration. What is your model number 3? Free undamped. Okay. Now first of all, we'll understand what is free, and then we'll understand what is undamped, and then we will understand what is free undamped. These words are very, very important. Now, what is free vibration? Okay. Now, let us say that there is a spring mass system. Again, I will come to the spring mass system. Okay, M, K, and now let us say that you are just giving an initial displacement. X is equal to initial displacement. X is equal to initial displacement. म्हणजेच काय, तुम्ही फक्त एक इनिशियल डिस्प्लेसमेंट दिलंस. मीन्स व्हॉट, यू आर नॉट अप्लाइंग अ कंटिन्युअस फोर्स. You have just given a small initial displacement. You have just given a small initial displacement x. No continuous force. No continuous force is acting on the system. No continuous force is acting on the system. Okay. Now guys, tell me what will happen. Anybody? Anybody can tell me if I am giving a small initial displacement x to the system. What can happen? What can happen? Just for your understanding, I am giving a small initial displacement x. Now already, if you don't understand, or if you don't remember, or if you haven't attended my lecture, please watch lecture number 1 of mechanical vibration. I have already given a name, mechanical vibration lecture number 01. Watch that lecture where what I have explained you. If you are giving us, if you are applying an external force F, okay, so what will happen? The work will be done and the energy will be stored in the form of strain energy. Energy will be stored in the form of strain energy in the spring mass system, in the spring, okay, and kinetic energy in the mass. And then this energy will get converted into the strain to kinetic or kinetic to potential and vice versa. Right? So this I have already explained. So similarly, in this case, if the initial displacement is given to the system, then the system vibrates on its own due to the internal elastic forces. What are the internal elastic forces? What are the internal elastic forces? Now, guys, I have already explained you that any system which is elastic and have a mass will vibrate. Means what? Spring, beam, right? So each and every system should have a mass and elasticity. Then and then they will vibrate. A rigid body which is not having a, you can say, elasticity, it should have a both elasticity as well as the mass, right? So the spring is nothing but elastic element, na? So what is the potential energy stored? 1 of k into x square. What is the kinetic energy stored? So what is the kinetic energy possessed by the mass? 1 of k into x dot square, right? Now, if you are giving an initial displacement x and now you are removing the force, म्हणजेच काय, तुम्ही थोड्या वेळासाठी फक्त त्याला हलवताय, थोड्या वेळासाठी तुम्ही त्याला जागा करताय, फक्त तुम्ही काय करताय, स्मॉल टॅपिंग करताय, स्मॉल डिस्प्लेसमेंट देताय, and you remove the force. Now after some time your system will keep on vibrating, Okay, and this system will keep on vibrating unless and until all the energy is dissipated into the atmosphere. Then such a system is called the free vibration. Now try to understand that in this case there is no artificial damping. There is no artificial damping. Very, very important. Means what? Why the damping is required? Damping is required to remove the energy or to dissipate the energy. But guys, now just I want to answer from your side. Is there any damping in this system, or it is a completely damping free system? There is no artificial damping in the system because there is no damper. There is only K and M. There is no C. Then how this system will come to the rest? Anybody? How does this system will come to the rest? This system will come to the rest, na? Even if you are giving a small displacement x, it will vibrate for some time and then it will come to the rest. Mass will stop moving up and down. Why? You are not. I am saying that you are not providing artificial damping. Then why in this case? Anybody? Then how is the resistance to the motion provided? How is the resistance to the motion provided in the system? We have discussed in the lecture number 1 and 2. Anybody? Who will provide the resistance to the system? Air resistance. Yes, 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 exactly. So there is a air resistance, but basically this air resistance is a negligible as compared to the artificial damping, and that is why this we are not considering air resistance as a damping, and that is why air resistance comes under the undamped situation. It is so air resistance is also called as a undamping. Means what? It is a negligible, ना के बराबर है. But air is there, and this air resistance, and also the resistance provided by these elastic forces. Not only air, but the resistance. म्हणजे, for example, let us say if someone comes you and started fighting with you, okay, so there is some internal power within you. It will start resisting, and you will also start fighting with you, or you will start, you can say, boxing, or you will start wrestling, whatever you can do. Okay, so this is called the internal resistance. This is called internal resistance. But if the third person comes and supports you and tries to fight with that another person, so this is called the external resistance. Okay, so this is the difference between the damping and undamping. Okay, that is the next part. So I hope you understand this. So such a type of vibrations are called the free vibration. So guys, just keep in mind, in free vibration, we are just giving a initial displacement. We are just giving a small initial displacement. Okay, so in module number 3 and in module number 4, we will always only study about the free vibration. For each and every system, we will give only a small initial displacement. Means what? After some time, the system will come to its rest condition. Basically, there are two conditions, transient and steady state. But if I will explain you these two conditions later on, okay? And the natural frequency, the frequency of a vibration, free vibration, is called as a natural frequency. Now you know what is omega, and I have already explained what is natural frequency. Natural frequency Fn is also equal to omega is equal to Fn. No, same. So this Fn or omega n is what? It's a desired frequency. So frequency of free vibration is called as a natural frequency. So how you define the natural frequency? The frequency of free vibration means what? When the system is vibrating, or when the system is initially displaced and started vibrating, the corresponding frequency is nothing but the natural frequency. Okay, so it is denoted by omega n. Okay, is it clear? Yes, tell me, have you understand this or not? Okay, so example is what? Oscillation of a simple pendulum, or even if I take an example of a stigma system. Okay, I will just explain this last point, what is force vibration, and then we will stop. Okay, now what is force vibration? If a system is subjected to the periodic external exciting force, then the resulting vibrations are called as a force vibration. Now basically guys, what is the difference? Okay, the difference is that in a free vibration, you have just given a small initial displacement x, but in force vibration, you are continuously applying a F. There is an external exciting force is continuously applied on the system. Then the resulting vibrations are called as the force vibration. Now the example of this free vibration is a simple pendulum. आता तुम्ही बघितलं पेंडुलमला आपण एकदा ऑस्ट्रेट केलं तर ते ऑस्ट्रेट होत राहतं and after some time it will come to the rest. But if you keep the same pendulum behind the glass, that is inside the vacuum, it will remain oscillating. Why? Because there is no air resistance there. No? Means you are keeping in the negative air pressure, right? Now, can anybody give me the example of force vibration in your day-to-day life where you are continuously applying the force and the system will vibrate? So that is called the force vibration. So this is your model number three, and model number four, and here this you will use in the concept in the model number five. So chalo, anybody I will give you the example, but just anybody, if you have understand the concept, what is the example of force vibration? In force vibration, you are continuously applying the force. In free vibration, you are just applying, giving the initial displacement one time or maybe two times. You are not continuously applying. So, tell me any example of a force vibration. There are a lot of examples which you are using in your day-to-day life. जे तुम्ही वापरताय तुमची सगळ्यात आवडती
Pendulum.
वस्तू which is your favorite what is your favorite you can say which is your favorite swing, okay, anything else? Hey, what about your bike, what about your car, the IC engine, the engines of a car,
Forced
engines of a
vibration.
car or engines of a bike, they come under the force vibration or not? Anybody? Once you start the engine, unless and until you stop the engine, the force from the engine, which is also called as the external exciting force, is continuously applied on the system. Na? Means what? From the engine, the vibration will be transferred to the chassis. From chassis, it will go to the maybe wheels, or maybe it will come towards you, towards the whole vehicle body. The vibrations are transmitted from the IC engine to the whole vehicle body, right? Na? So there, unless and until your engine is stopped, you are applying a continuous force. Okay, so IC engine is one of the example. Any example? Doorbell ring. What about doorbell ring? Whenever you are pressing, see there, if you keep pressing on button, the doorbell will ring. If you remove the button push of your thumb, the doorbell will not ring. Means what? There also you have to apply the continuous force. Cycle, okay, cycle is also force vibration, right? You have to continuously paddle. Next, compressors. What about compressors, electric motors? Okay, so all comes under the force vibration. So vibration of IC engine, electric motor, centrifugal pump. Okay, त्याच्यानंतर you can call it a dentist drill. Okay, dentist drill, washing machine, vibrations of a water inside the washing machines. Okay, what else? Dentist drill, face face massage, face massage machine, right? Lot of equipments are there, guys, where you are using a force vibration. Now, please message me. Have you understand the difference between the free vibration and the force vibration?